7. Actually, have you seen that? You can have below 0, minus 10, minus 40 degrees Celsius. You travel somewhere, and after a while, the tires, after many hours, you cannot touch the tire. It's so hot, you cannot touch it. It's burning. Have you seen that? Yeah. When you go to Los Angeles, you travel for 3-4 hours without stop. 3 hours without stopping, 4 hours. After you come up, touch the tire and see how hot it is. You cannot touch it. And it's because of friction. Okay? So 11 is work. It's not because of energy transfer from the road. The road is minus 10 degrees Celsius, could be that cold. And it's not because of friction, because of the axis. Not really. Well, okay, that's an easy one. How about W? I mean, W. Okay, how about 14? I guess the opposite. Okay? So, always put the problem like this. The examples are different. You get the idea, then you do well, right? Okay, let's do this one. Where's the band? Did it come yet? We need the break. Don't you need the break? No?
Yes. You do need it, buddy.
For your health. Only if you drink the good stuff. Otherwise, you're not going to count. It doesn't matter how many times the teacher will say things to your health. Right? Right. Okay. So let's do this. Number 16. Okay, we need to draw the phase diagram. So, what's the phase diagram? We have two axes, right? We have two axes. One stands for pressure, and the other, let's put atmosphere because give it atmospheres. And the other stands out for temperature. Okay, and then it says to draw this diagram, phase diagram of the substance, you know the following information. So you have triple point, normal boiling point, and now you have to really consider all this information in order to do it right. So, one thing that you know is, you know a phase diagram how it looks like. So you start with a triple point somewhere here, right? And then you know you got a line like this, kind of. Then you go a line kind of like that. And then you go a line like this or like that. And you know it's going to be the slope like this, negative, if it's water. And if it's anything else, it's going to be like this. So we'll make an assumption, probably it's talking about something else, not just water. But we'll see. Alright, so tentatively, I will do this. Because I'm not sure if that will go. Maybe it's water and I have to do it the other way. We'll see how we're going to decide, right? I just take the chance that probably it's like this because it's everything else except water, practically speaking. Very rare. Water and maybe another thing. Very few substances they have the negative state. Okay? I took the chance to do it like this because probably that's what it is. Okay, so now, triple point is 20 degrees Celsius, so that means if I do this one here should be 20 degrees. And then it says pressure for the triple point is 0.75 atmospheres. Great. Now it talks about normal melting point, normal boiling point. Normal means under external pressure of 1 atmosphere. So I have to find 1 atmosphere where it is. So if this is 0.75 and this is 0, it better be a little bit higher, right? So let's say it's somewhere here. So that's going to be 1 atmosphere. And if I want to find out melting point and boiling point, I will have to do what? Draw a line, right? And wherever that line meets these two curves will give me the normal, right? Boiling point, normal melting point under external pressure of 1 atmosphere, right? So boiling point tells me it's how much? 200. So at 1 atmosphere external pressure, that will give me the normal boiling point. This is the curve that is between liquid and gas, and this is between liquid and solid, right? And this is between solid and gas, right? So from here, if I do this is going to give you what? The boiling point, 200 degrees Celsius. Yes? And the melting point, it tells me it's 25 degrees Celsius. So if the triple point is at 20, and the normal melting point is 25, should be somewhere here, let's say somewhere here. Just, we don't care about exactly, right? So it should be somewhere here, 25 degrees Celsius, that would be the melting point. Does that make sense? In 1 atmosphere? Yes, it makes sense, you can see it. It could not be this way, because then, if it was like this, the normal melting point should have been less than 20 degrees. So it cannot be a compound, a substance in general, it could be an element. A substance that has a slope. Melting point is a function of external pressure to be with negative slope. It couldn't be that way, because the temperature of normal melting point is higher than the triple point temperature. So that's why we know it's going like more like this, right? Not like that.
Professor, what about the critical point?
We didn't talk about it?
It's not there in the question.
We did already put it, didn't we? Here is 20 degrees and here is 0.75 atmospheres, right there.
Not critical.
Oh, critical point. Does it talk about critical point? Well, then we don't talk about it. Where are they? They were in May. Yeah. Really? Of course. Let's see. Just a second. Let's finish this question. Yeah, bring them. Bring your bodies. The critical point should be somewhere here, right? Somewhere there. All right, we're going to have fun for 10-15 minutes.